Okay, now let's look at quantile bins or qcut, pd.qcut. So now we are not going to be looking at or specifying the intervals themselves. We will just simply say how many should go in each interval, and pandas will figure out what those intervals are. Okay. It's like equal, the PD cut with the equal width, but it is not about the equality of widths, but it is equality of contents within intervals. So here if you do PD qcut 4, then it's going to convert into 4 bins, and the number of observations in each bin will be the same. Okay, approximately. It's not, depending upon how many observations are there, it's not, sometimes it may not be exactly equal. Okay, it will be close. So here, okay, so let's say that if we do value counts, so actually, it turns out to be pretty bad. Because of that extreme value, the last one has only 1 observation. The rest of them, it is a very small, this particular data set is so small, and it's kind of hard to get equal size. But that's what it tries to do at least, PDQ cut. Okay. And here I'm using labels to specify which quartile it's going to go to. Okay, so now if you say 3, then it's going to divide the data into 3 percentile ranges. Okay, first sort them in the first third, second third, and the third third. And then you can also do quantiles with user-defined percentiles. Okay, so here you have like instead of bin limits, then here we have quantile limits. Okay, quantiles will have to go from 0 to 1. So you start with 0, end with 1, and then in between you specify where the cutoff points must be for each bin. Okay, and then again, so here you get the value counts, and once again it's based on the percentiles that we have specified. So if you leave that part out, if you leave the value counts out, then it's going to just give the limits. All right, so let's look at your turn here. We're going to start with a copy of DFQ6. So make a copy of it, DFQ9. Okay, and we want bins for pulse from 0 to 200 in increments of 50. So let's say we need to find the bin list. So bin Q9B. Okay. So it has to be a list. So now we specify the cutoff points. So we want to go from 0 to 200. So start with 0, and we want to end with 200, but in between, what? We want in increments of 50, so it's going to be like that. So these will be the bins, all right. And then we can dfq9 dot what pulse, right? Well, we have to start with pd.cut. pd.cut. Okay, and what do you want to cut? We want to cut dfq9.pulse. That's what we want to cut. And then we want to use bin q9b as the bin. Okay, so it's going to create a column of bins like this. If you want to put this back in to dfq9, we can do that. Okay, but right now it's not saved anywhere. It just creates the bins and that's it. It's thrown out. Okay. Now you can add labels. Does it say with proper labels? So, well, labels, whatever that we create is going to be not very different from the default labels. So we can create labels for each of them. So 0 to 50, 50 to 100, 100 to 150, 150 to 200. Okay, labels equal to, okay. Okay, let's save this. Okay, we don't want, okay, so suppose, there are many different ways. Suppose you don't want to keep it in the data frame, okay, but you want to use it in preparing the frequency distribution. So we can say, we can create just a pandas series like this. So bin pulse, so that would be bin pulse. Then we want, okay, everybody done B, A and B? Are you good with B? All right, so now we have a column called bin pulse, which has the bins, right? And C, we want frequency distribution, so we just say bin pulse value counts. Now, by default, this is sorted by the frequency count in descending order of frequency counts. Okay. But normally, when you prepare frequency distribution, you want it to be sorted by the index. So we can add sort index. Then you'll have the frequency distribution sorted by index. Okay? Everybody got it? Okay, now D is create 5 equal width bins for pulse and create a distribution, all right? So pd cut dfq9 dot pulse, right? And we want 5 equal bins, so all we have to do is to say 5. Okay, so that's going to create 5 equal bins, okay, and equal width bins. So these are, we are using cut, So these are equal width bins. And we want frequency distribution, so we have to do value counts. Okay. And you see these are about 30 in width, equal size. Okay? And then E is create 5 equal frequency bins. Okay, so equal frequency means you have to use qcut. Okay. PD qcut DFQ9 pulse, and then 5. Okay. Now I'm not using labels and things like that, but you know, we have already seen how to do that, so I'm leaving it out. So now you see, look at the difference between the bins. Okay, same 5, but one is cut and another one, the other is qcut. So cut will be equal width, so the frequencies are quite different. Okay. Now here the widths are different, okay, and the frequencies, even though they are not exactly the same, is much less different than cut.